In this video, we'll be evaluating a series circuit, and we'll be answering the following questions. What is the total voltage? What is the total resistance? What is the total current? What is the voltage across each resistance, V1, V2? And lastly, we'll apply the KVL, or Kirchhoff's voltage law. This is my series circuit right here. I've got a 10-volt source, and I've got a couple of resistors, R1, R2. R1 is 500 ohms, R2 is 200 ohms. Since R1 and R2 are in series, and both of those resistors is across the 10-volt source, then the total voltage is 10 volts. Next question. What is the total resistance? The total resistance is the sum of R1 and R2. Therefore, RT equals 500 ohms plus 200 ohms. RT equals 700 ohms. $700 is the total resistance. So now the next question is, what is the total current? The total current equals VT, the total voltage, divided by RT, the total resistance. VT is 10 volts. RT is 700 ohms. $700 is the 10 volts equals 0.0142 amps. The total current is 0.0142 amps. Now we have to determine what is the voltages across each of these resistors. Whenever a current flows through a series resistance, it creates a voltage drop across each resistor. The voltage drop is determined by Ohm's law, which says V volts equals I current times the value of the resistance. Now, let's evaluate the voltage across the 500 ohm resistor. The current is flowing through the 500 ohm resistor of 0.0142 amps. 0.0142 amps times the resistor value of 500 ohms. Equals 0.0142 amps equals 7.1 volts. Now, that same current of 0.0142 amps is also flowing through the 200 ohm resistor because these two resistors are in series. So now, zero point zero one four two amps times 200 ohms. Zero point zero one four two amps times 200 ohms equals 2.84 volts. The voltage across V1, the 500 ohm resistor, is 7.1 volts, and the voltage across V2, the 200 ohm resistor, is 2.84 volts. .1 volts, 2.84 volts. Now lastly, we will apply the KVL. Now, the KVL says the volt source plus the algebraic sum of the resistances plus minus V1 plus minus V2 equals 0. We have 10 volts, a plus times a minus is going to give you a minus, minus 7.1 volts, plus times a minus again is going to give you another minus, minus 2.84 volts, equals 0.06 volts. Now, why is it not 0 volts exactly? Well, the answer is that when I did these calculations, okay, there were some more decimals after the decimal point in the voltages, and I just didn't include them in the final calculations. I kind of just rounded it off. But this is essentially what we're looking for. And this brings me to the end of the video, and I'll see you in the next video.